In this section, let's see the die casting techniques. Let's see the complete overview of the die casting process. The molten metal is forced into the reusable steel die cavity. The die opens after solidification and the part is ejected. That's a simple science behind this die casting process. And why we are using high pressure or pressure filling helps. High pressure fills thin sections quickly before freezing starts. It gives good dimensional accuracy and consistent surface finish. And what are all the automobile applications best suited to non-ferrous alloys for repeated high volume output, used for housings, covers, brackets, and similar production parts. There are two distinct type of die casting. One is hard chamber cycle. Let's see that fill the injection chamber with the die locked molten metal flows into the built-in chamber. It's a molten metal. This prepares a measured shot close to the die cavity. Inject and hold pressure. The plunger pushes the metal through the passage into the die. Pressure is maintained during cooling to finish filling thin areas. Open the die and eject. After solidification, the plunger retracts and the die opens. Ejector system pushes the casting out for trimming and inspection. Let's see the principle of cold chamber die casting. The cycle starts how the metal is filled. Molten metal is ladled into a separate short chamber each cycle. This keeps the furnace and injection system physically separated. Injection and filling. A hydraulic ram pushes the shot into the die at high pressure. Pressure is maintained during cooling to help the cavity fill. When it is preferred, used for alloys that are less suitable for hard chamber contact. Common choice when high heat would damage the injection unit. Let's do a simple comparison of hot and cold chamber die casting. In hot chamber die casting, the molten metal feeds an internal chamber when the die is closed. A plunger injects and holds the pressure during cooling and solidification. Because metal stays in the machine, cycle time is typically faster. Now, let's see the cold chamber die casting. Molten metal is ladled into a separate short chamber each cycle. Separate short chamber each cycle. A ram forces the metal into the die and maintains pressure. Used when molten metal contact could damage the injection system. How to choose in practice? Select mainly by alloy behavior and long-term machine durability. Die casting cross-sectional view. Now you see clearly how what is going on inside the die halves and cavity. The fixed half and moving half close to form the die cavity. Accurate alignment keeps the cavity sealed during pressurized filling. Pressure injection path. Molten metal enters the short chamber, then the ram advances. The ram forces metal into the cavity and holds pressure to solidify. Ejection and reset. After cooling, the die opens and ejector pins push out the casting. The ram withdraws and the die closes to repeat the cycle. Gravity and centrifugal casting. The gravity die casting is a permanent mold. Molten metal is poured, gravity fills the reusable metal cavity. The mold opens after solidification, the casting is removed. In centrifugal casting, rotating mold. A high speed rotating mold drives metal outward by centrifugal force. The outer profile can vary. The bore becomes nearly round naturally. Where each method fits best, gravity die casting suits repeatable shapes where a permanent mold is practical. Centrifugal casting is ideal for round or hollow parts like rings and sleeves. In this section, let's see the Cupola Furnace operation, cross-sectional view, working principles in detail. Let's understand first the main use or purpose of Cupola Furnace. The Cupola Furnace is used primarily to melt cast iron for casting. Where it is commonly used? Typically in small foundries, making repeated iron castings for parts. Why students should learn it? Knowing Cupola operation supports better control of iron casting practice. Let's understand the zones clearly. There are three distinctive zones. We see the charging and heat flow zone. Charge moves downward while hot gases, hot gases rise and heat it. This creates a distinct temperature zone from top to bottom. Rules of charge models. Hot zone, warm zone, melting zone, and earth. The roles of charging materials. Coke provides the main heat needed for melting cast iron. Limestone works as a flux, helping separate slag from iron. Why zones matter in practice? Iron melts and collects lower, while slag forms and is removed from the top. Controlling zones improves temperature control, slag handling, and quality. We can clearly understand from the picture in the right side the cross-sectional view of Cupola furnace. The main construction parts. The steel shell is protected by an inner refractory lining. The charging door feeds a metal coke and flux from the top, air and melting region. Air blast enters through two areas near the lower furnace. The melting zone forms just above two areas as the charge descends, tapping and slag removal. Molten iron collects at the bottom and exits via the tap hole. Tighter slag is drained separately through the slag hole. Let's understand the common casting defects. For all the process it is happening there. So filling related defects, misrun occurs when metal freezes before the cavity fully fills. Cold shut forms when two fronts meet but do not fuse. Solidification related defects, shrinkage, cavities form as metal contracts during cooling. Microporosity is a fine voids trapped inside the solidified casting. Thermal stress defect, the hot tearing is cracking when contraction is restrained in the mold. Why defect recognition matters? These are all very, very important defects. We have to keep in mind while designing the die pattern and even the parts. Use defect patterns to adjust gating, pouring temperature, and mold design. Now here we have to understand how to choose a proper process because casting has a number of processes we have learned so far. So choose sand casting when the part is larger and you need flexible lower volume production. A gated closed mold can feed complex cavities reliably. Choose investment casting when you need intricate geometry and the fine detail from a wax pattern process. Multiple small parts can be cast together on a sprue tree. Choose die casting when you need high production rate using a reusable metal die. Pressure filling improves repeatability and supports thinner sections. What is that from casting? Automobile engineer can take it. What is in it for automobile engineering? So choose the right casting process, match the method to part geometry, alloy, quantity, finish, and cost. Use expandable molds for flexible and the permanent molds for repetition. Cupola furnace, Cupola furnace, some people say, still matters. Cupola furnaces are widely used to melt cast iron in foundries. Impact on automotive work. Process understanding improves the design choices, manufacturing control, and quality checks. Defect awareness helps the temperature, flow paths, and solidification behavior. Thank you. Thank you for watching this video.